There are objects in the universe so massive, so powerful, that they push the limits of what physics should allow. Places where gravity bends reality itself, where time slows, where even light cannot escape. This is not a star, not a galaxy, but a darkness so large that it should not exist. Far beyond our galaxy lies one of the biggest black holes ever discovered. A black hole so extreme that its size challenges our understanding of the universe. Its name is TON 618, and it may be one of the few objects we know that truly breaks the limits of cosmic scale. TON 618 lies near the border of the constellations Canes Venatici and Coma Berenices. When astronomers first recorded it in 1957, it appeared to be nothing unusual, just a faint blue point of light among thousands of distant stars. At the time, no one suspected that this tiny speck was hiding one of the largest objects ever found. Years later, scientists studied its light using spectroscopy, and the pattern did not match a normal star. The wavelengths were stretched, shifted toward red, a sign that the object was extremely far away, so far that the light reaching Earth today began its journey when the universe was still young. Long before our sun existed, long before our galaxy looked the way it does now. At that distance, the object itself cannot be seen directly. What we see instead is its glow, because TON 618 is not just a black hole. It is a quasar, one of the most powerful phenomena in the universe. A quasar forms when a supermassive black hole is feeding. Gas and dust fall inward, spiraling toward the center, but the material does not fall straight in. It forms a disk spinning faster and faster as gravity pulls it closer. Inside this disk, matter is heated to extreme temperatures. Collisions, friction, and magnetic forces turn the disk into a furnace hotter than most stars. The energy released is enormous. So enormous that a quasar can outshine the entire galaxy around it. This is why TON 618 can be seen across billions of light years. Not because we see the black hole, but because we see the matter falling into it. Jets of plasma are launched from its poles, streams of particles moving close to the speed of light. Each jet stretching for millions of light years, long enough to cross entire galaxies. The energy from these jets can shape the galaxy itself, blowing away gas, stopping new stars from forming, changing the course of cosmic evolution. TON 618 is one of the brightest quasars ever discovered, but its brightness raised a question. If the glow is this powerful, how large must the black hole be to create it? At the center of TON 618 lies a black hole with a mass of about 66 billion suns. For comparison, the black hole at the center of our galaxy, Sagittarius A, has about 4 million solar masses. TON 618 is more than 16,000 times heavier. Its event horizon, the point where nothing can escape, is enormous, hundreds of billions of miles across, large enough to swallow the entire solar system with space left over. If it replaced the sun, every planet from Mercury to Pluto would orbit inside the darkness. Near the edge of the event horizon, gravity becomes overwhelming. Light bends around the black hole. Time slows. To an outside observer, anything falling toward the horizon would appear to freeze. trapped at the edge of eternity. Closer still, the sky would be filled with a ring of fire, light from the disk bent by gravity into a glowing circle around the darkness. Beyond that point lies the singularity, a place where density becomes infinite, where our current understanding of physics breaks down completely. But the size of TON 618 creates a bigger mystery. Not what it is, but how it formed. Supermassive black holes are thought to grow slowly. They begin as smaller black holes, the remnants of massive stars. Over time, they pull in gas, consume stars, merge with other black holes, growing larger over billions of years. But TON 618 existed when the universe was still young. Its light began traveling toward us when the cosmos was only a fraction of its current age. That means this black hole must have grown at an incredible speed, faster than our models predict. There are limits to how quickly a black hole can feed. If too much matter falls in at once, radiation pushes it away. This limit is known as the Eddington limit. It should prevent black holes from growing too fast. Yet somehow, TON 618 became enormous anyway. Either it started much larger than we think possible, or the early universe was far more extreme than we once believed. Its existence forces scientists to question how black holes really evolve, and whether there are objects even larger still waiting to be found. Quasars like TON 618 are not only destructive, they are also useful. Because they are so bright, their light travels across the universe for billions of years. On its way to Earth, that light passes through clouds of gas between galaxies. Each cloud leaves a signature in the light. By studying these signatures, astronomers can learn what the universe looked like long ago. They can measure the chemistry of early galaxies, see how matter was distributed, understand how the first stars formed. Quasars act like beacons from the past, and TON 618 is one of the brightest beacons we have ever seen. It shows us a time when the universe was young, when galaxies were still forming, when black holes were growing faster than we thought possible. It is both destroyer and guide, a monster that helps us understand where everything came from. The universe is full of extremes, but every once in a while we find something that goes beyond them. TON 618 is one of those objects, a black hole so large that it challenges our theories, so bright that it can be seen across billions of light years, so old that its light began traveling before our planet even existed. It reminds us that the universe is still not fully understood, that the biggest objects may reveal the biggest mysteries, and that somewhere out there may be black holes even larger than this one. Join us next time as we explore more mysteries of the universe.